Right, then you may have to calculate the dissimilarity of numeric attribute. If you have numeric attribute, you can use the equilibrium distance, or you can also use the Manhattan. And also there is Minkowski distance. So this is one of the popular distance measure as well, where it combine the calculation of equidistant with Manhattan, and there is some changes somewhere. Um, if you have those ordinal variable, so you know that ordinal variable is a data type in range in order. So the ordinal variable can be discrete or continuous. So the order is very important in terms of rank. So for example, if you have small, medium, large, you can have the ordinal variable into ranking 0, 0.5 up till 1. Usually we normalize the ordinal variable. So you may refer to the additional material on how to calculate the origin or ordinal variable. Okay. Next is on the attribute of mixed type. Okay. There is some formula inside here, and you may refer it in the additional video as well. Then if you have unstructured data, for example, you want to cluster document, okay, so you can use the cosine similarity. This is actually will be repeated in the text mining. Next is on the major clustering approaches. So there are a lot of approaches. These two will be covered, okay, in this lecture, and these two is the extra approaches. Okay, you may, if you would like to do further research on it, you may search for it in the web. Okay, first we have partitioning approach. So in partitioning approach, it is constructing various partition, and then we evaluate them with some criterion. For example, we minimize the sum of square error. So the typical method of partitioning approach would be k-min, k-midoid, and also Clarent. In hierarchical approach, it is a method to create a hierarchical decomposition, okay, of the data or object using some criterion. So the typical method of hierarchical would be Diana, Agnes, Birch, and also Chameleon. Density-based approach is an approach that is based on connectivity and density function. Grid-based approach is based on multi-level granularity structure, a finite number of cells. So these are the typical method: steam, wave clusters, and also click. So when we talk about the distance between clusters, okay, if it is in single link, meaning that you have smallest distance between an element in one cluster and element in another cluster. If it has the cluster is having complete link, meaning that it has the largest distance between an element in one cluster and element in another cluster. For average, it is the average distance between an element in one cluster and an element in another cluster. Centroid is the distance between the two centroid of two clusters. So, for example, two centroid, where is the centroid? Okay, we need to calculate them. And midoid is the distance between two midoid of two clusters. Okay, so usually midoid is a chosen centrally located object in the cluster when min or centroid cannot be defined. Let us take a look at the partitioning algorithm, the basic concept of it. So partitioning algorithm is when you partition a database, okay, a database D into of an object. So an object meaning that the row, okay, into a set of k clusters such that you will be having minimum sum of squared distance. So meaning that you will be getting the lowest value of the sum of square of your distance dig. Okay. So one method of partitioning algorithm is k-mean clustering method. You are given k where the k-mean algorithm is implemented into 4 steps. One is partition object into k non-empty subset, and then you are going to compute the seed point as the centroid, okay, of the clusters of the current partitioning. So centroid here is the mean point of your cluster. Okay, when you say that you're having the mean point, so you are going to add all of the point in the cluster and then divide it with the value of your n, okay, or value of point in your cluster. And then you are going to assign each object to the cluster with the nearest seed point, and then you will need to go back to step 2, and you have to stop when the assignment does not change. What does this mean? Let us take a look at this. Okay, before that, let us take a look at the two different k-mean clustering here. So this is the original point, okay. This is the optimal clustering. Okay, so this is the optimal clustering. So in optimal clustering, you have 3 clusters here with global minimum of some squared error with 3 clusters. However, sometimes k-mean clustering can stuck in a local minimum, okay, where it is a suboptimal clustering. It is not that optimal because it is not clustering well in this cluster. For example, you cannot see a clear cluster here, right? Okay, and this cluster here, you can see the intercluster distance is quite high here, but it is not it say that it is in one cluster, but it is not one cluster. So this is the k-mean clustering method. So let us open up back or you have to refer back on your slide here. Okay, so first thing first, you need to partition object into k non-empty subset. So for example, you say that you want your k or your cluster to be 2. Okay, so when you say that your cluster is 2, you have to compute the seed point as the centroid of the clusters. Okay, so here your k, your first seed point, okay, your first seed point will be initialized as this point and this point here. Okay, for example, we have 1 3 and also 9 4 here, and then you are going to assign each object to the most similar center. So you say that this is the center, okay, this is the second center, this is the first center, this is the second center. So you are going to assign each of these objects with their similar center. So you are going to compare it with this one and this one as well. Okay, the most similar value or the similarity is high, so it will be clustered in near to the center, to the similar center. Okay, then you are going to update your cluster. Okay, you are going to update the cluster mean. Okay, so for example, this is your first iteration of your centroid. Then you have to define a new centroid here based on the cluster mean. Okay, so for example here you have this cluster, these light blue clusters with dark blue clusters. Okay, so you have to calculate the mean of all of these cluster to create another seed. Okay, another seed or another centroid. So this centroid is basically defined based on the calculation of the mean from the first cluster here, and same goes to this deep blue cluster here. It will get this what they call that centroid here. Okay, then once you get the new centroid, okay, you have to reassign the points again, or you have to reassign the object again with the new centroid. Okay, so for example, you say that, oh, okay, now my new centroid is somewhere around here. Okay, sorry, it is not there, it is somewhere around here, right? Let me just erase this. Okay, it said that your new centroid is somewhere around here. Okay, this one. Okay, so you have to, okay, what you have to do is you need to compare all of the object or all of the point with the new centroid here. Okay, so that is why if you take a look at this point here, before this it is in dark blue color, but then when it has been compared with the new centroid, it said that, oh, okay, this is more similar to this cluster. Okay, so that is why this light blue, this new light blue point is being clustered in the first cluster here. And meanwhile, this light blue here has been calculated the distance as well. So it said that, oh, okay, if I compare this with the centroid, okay, centroid here, it said that the distance with this cluster is much nearer. Okay, so you have to update the cluster means up till you see that you are having minimum error using some square error, minimum error. Usually the error is being reduced per iteration. Or sometimes if you see that there is no changes, okay, the assignment has no changes, for example, the clusters are not changing anymore, meaning that you are having the optimal value of cluster. But one thing that you have to careful with is sometimes it can stuck in local minimum. Let us take a look at this example here. Okay, so this is your point. So you have 10 point, okay, 10 object or 10 row with 2 attribute. Okay, so this is attribute X and this is attribute Y. Please don't get confused. This is not class, yeah. This is another attribute. Okay, you have to find 2 clusters. It said that you have to find 2 clusters using key mean. Okay, so when you want to find 2 clusters, meaning that you have to initialize 2 centroid, right? So the first centroid being initialized is this one. Okay, let me change the color again. Is 3, 4. So this is the centroid, and C2, where is it? 7, 4. So this one is another centroid here. Okay, this is the seed, yeah. You have to compare all of this point with the centroid. You need to measure the distance mean between this point with this centroid here. Okay, how are you going to do that? You have to use, usually, okay, in given question, okay, it will be given in the question. You have to find distance using what method? So usually in the exam, you say that, okay, you have to use Euclidean distance, for example. So you need to calculate the distance between each point in previous slide, that 10 point, with the centroid that has been determined. Okay. Usually the formula of equilibrium distance will be given, so you don't have to worry that much. Yeah. Okay. Next is, first we have to calculate the distance. Okay. So this is the method or the table of calculating the distance. Okay. When we calculate the distance, it said that the first point is 2, 6. Okay. We have to compare, so we need to find the distance of 2, 6, compare it with the centroid of 3, 4 here. Okay. How are we going to do that? We have to use the equilibrium distance. So we are comparing the first point with the first cluster, the first centroid cluster, that is 3, 4. Okay, so D 2, 6, we have to compare it with 3, 4 here. Okay, so using the equilibrium distance, 2, okay, will minus, okay, C is what? C is 3, 4. Okay, X will minus, X1 will minus X2, Y1 will minus X2, Y2. Okay, so 2 minus 3 square plus 6 minus 4 square, and square it again, because this is the formula for equilibrium distance. So can you calculate how much, or what is the answer? So it will be square root of 5, value of 2.23. So this is the value of distance between first point with the centroid. Okay. Next is the first point you are comparing with the second centroid. Okay. I will just draw it to you so that you cannot get confused. So this is the first centroid, for example, and this is the second centroid. So you have another one that is 2, 6 around here. Okay, 2, 6 possibly will be around here, right? Okay, so you will be comparing this point with these two centroids so that you can know which cluster it will belong to. Okay. Next is comparing it with the second cluster centroid, that is 7, 4. 7, 4 is around here. So same formula. Okay. Same formula. You say that 2 minus 7. Okay, 7 is here. Okay, x2 plus 3, sorry, it is 6, right? 6, because we are comparing D to 6 here. 6 minus 4, square, square, and square root. So you will be having 5.39. Okay. Now, when you want to define the cluster, which cluster does it belongs to, okay, what you have to do is you need to see which distance is smaller, okay, meaning that it will be nearer and it will be more similar. Okay, if you take a look at these two points, okay, these two value of distance, okay, you see that the first point, 0.26, is actually nearer to the first cluster, the first centroid cluster, that is 2.23 here. It will be somewhere around here. So it will be clustered, okay, into this centroid. So that is why we say that, okay, centroid, the point will be clustered into cluster 1. So this one we can say it as cluster 1, and for example this somewhere around here would be cluster 2. Then you have to calculate up till point 10. Okay, so it says that point 1 2, 3, 4 is belong to cluster 1, while 0.5, 6, 7, 8, 9, 10 will belong into cluster 2. Next is you need to do the iteration, because this is not the optimal cluster yet. Okay, so that is why when the examination question will say, okay, apply k-mean algorithm, okay, to produce two clusters, for example. Okay, so you need to do the process of finding the optimal cluster. How are you going to do that? You have to calculate the new centroid based on the mean of your new cluster. Okay. So you know that the value of your, what they call that, new clusters, okay, is 0.1, 0.2, 0.3, and 0.4. So in order for you to get the mean of the new centroid, okay, what you have to do, you need to calculate the mean of x and the mean of y for every point. So this is for 0.1, okay, 0.2, 0.3, and also 0.4, so that you can over 4 because you have 4 value here. Okay. So after you have calculated the mean, okay, it said that your new centroid, okay, so this one will be known as new centroid, that is 3, 6.25. So this is x and this is y. So if it is somewhere around here, it said that it will be 3 and 6.25. For instead of here, it will be somewhere around here, right? Yeah, okay. Because it depends on your point here. You are calculating the mean of all of these points, okay? These 4 points. So the new mean would be somewhere around here. Same goes to cluster 2. Okay, so those with these clusters, you have to find the mean of these 1, 2, 3, 4, 5, 6 point here, and then you have to define new centroid. Once we have found the new centroid here, okay, we need to go to the second iteration on optimizing the value of the cluster. So what you have to do is you need to calculate the distance of all of these 10 points with this new centroid. So for example here, your new centroid here is 3, 6, 2, 5, right? Okay. Yes, new C1 is 3, 6.25, okay. And this one is, you have to calculate it again. Okay. So once you have calculated the distance using Euclidean distance, okay, you can see or you can compare whether this one or this one is smaller. So let's say, okay, this value is smaller than this value. So meaning that now the cluster is being assigned to cluster number 2 instead of cluster number 1. Okay. Once you have seen the what they call that, the clusters is not giving any changes, if you go to the next iteration, so that is mean your stopping condition is being what they call that, agreed. So in order for you to choose the initial centroid, sometimes randomly selected initial centroid may be poor. So you are limiting the random, you have to limit random initialization. Then you have to perform multiple run and then select the set of clusters with the minimum sum square error. And also you need to choose or you select the first point at random, or take the point of all that take the centroid of all point. Then for each successive initial centroid, select the point that is farthest away from the initial centroid already selected. So this is how you can do in choosing the initial centroid. In order for you to evaluate the k-mean clusters, okay, the most common measures is getting the sum of square error. Okay, so for example, you have the distance and you have to square it. Okay, for each point, the error is the distance to the nearest cluster. So to get the sum square error, we square this error and then we sum them. Okay. This one you may take a look at it by your own self, yeah. So this is example of using k-mean, and then this is the cluster analysis for data mining. How many clusters? Again, we are talking about how many clusters. But then there is not a truly optimal way to calculate it. Okay, heuristic will often being used. Okay, based on the past experience. And we will be looking at the sparseness of the clusters. Okay, we have to choose the number of clusters so that adding another cluster would not giving a much better modeling of the data. And usually it based on the rule of thumb is based on this formula n, meaning that n number of points. Let's say just now we have 10, okay, divided by 2 to the power of half. Okay, so that would be your number of cluster. However, in k-mean method, there is strength and weaknesses as well. Okay, in terms of strength, it is efficient. Okay, but however, most of the time, it will stuck at the local optimal. Okay, and then there is time that what they call that k-mean is only applicable when mean is defined. Okay, so we have to get the average. So this is when we want the average, meaning that we are dealing with numerical data, right? But what about when we have the categorical data? How are we going to find the mean now? So we need to specify the k, the number of clusters in advance. Okay, k-mean is sensitive to noisy and outliers, right? And it is not suitable to discover clusters with non-compact shapes. There's another variation of k-mean, okay, that is k-medoid, okay, this one, okay, you can read by your own, but usually in final exam, it will be covered on k-mean. Okay, you have to read on this as well, and the last two slides. So that's it. If you have any question, you may ask me in the WhatsApp group, or you can PM me later on. Okay, thank you everyone. Assalamualaikum.